Okay guys, now I'm going to make a huge favor to everybody who bought this Dynam 3GS Gyro and is not an expert in calibrating these things and having trouble. I'm going to share what I found out and how I succeeded to some extent to use it on some special device that I have been building. Now I will go over the couple of screens and try to give you information on how to adjust some of the things and what they mean. Now I didn't use these buttons at the top, so there are some preset adjustments here for for your device. So my device that I'm working on is pretty special. It's not like anything else, so I just have to make my own adjustments. So it was really a pain in the butt, but I found a couple of things. First of all, in the first screen, uh, first of all, getting connected. After you download the software, uh, here's how you gotta be connecting. Turn on the transmitter, power up the receiver and the Dynam. After making all the connections, the connections are given in the software, how you should make the connections. Power up the receiver, wait until the light on the gyro turns either solid blue or red, and then hook up the cables, and then find the port from here. There are ports from 1 to 20, and then hit connect. It will hopefully connect when you find the right port. How are you going to know if you're at the right port? The light on the USB connector is going to light up, blue and red lights. So that's how you know. And then after you get connected, let me give you information about these controls. Now this agility, roll, pitch and tail rotor. Agility means when this is high, the servo is responding to your move more than when it's low. So if this is low, if you're hitting the stick a little bit, servo is moving at 1 millimeter. When this is too high, it's moving 2-3 millimeters. So it's the sensitivity of the gyro against your input with the stick. So that's all it does. Gain is the sensitivity of the gyro against the move. I mean, when you move the device from side to side, if the gain is too high, the gyro is going to respond more. If it's low, it's going to respond less. So basically, this is the sensitivity of the gyro, how much it compensates. So that's it. And we have the pitch and the same controls for pitch. And then actually I couldn't still figure out what this tail rotor, the yaw and yaw rate L and yaw rate RS are, because I'm not really having too much trouble with the tail rotor right now. I had it when I first set it up, and I'm going to show you what to adjust to get rid of that. But now I just put them down here, and the gain is the same, so that's how much it's going to compensate when there's a move. So that's that. And then let me show you, go through the setup, and then it shows how to hook it up. And then here now, when I first set it up, I had huge problem with the yaw, actually with the rudder. The rudder wasn't actually stable. It was just moving from side to side in an uncontrolled way. So I just couldn't figure it out until I found this. At this right bottom here, it says normal AVCS tail gain. So there is an adjustment here. This adjustment is the one which corrected. It was on the AVCS side, so I pulled it back to normal side, like 30, 34, and then it corrected itself. Until I found this, I tried every single thing, but I couldn't find it until I figured it from here. This is basically controlled with the 5th channel on your transmitter. It's the 5th channel, okay? Another tip is here, there's collective pitch. For your 6th channel to control this collective pitch, your transmitter should be in the helicopter mode. If it's in the plane mode, it's not going to control this. So you gotta be careful about this one. And these basically show the controls from transmitter, and to set the neutral points, areas, and things like this. Everything's working. This is based on how you're installing it, your installation direction. It's very simple. Here there are the servo types. Mine are digital, so that's what I selected. But even when I select the analog, it worked the same. So I don't know what exactly the difference would be. Now here it gives the swash plate types, the 90 degree, 120 degree mechanical mixer and things like that. And also you have the options here for the plane, delta wing and things like that. So here one very good feature is that you can set the trim of the servo from here. You can adjust those so that your control surfaces are at the mid-range. You can do this electronically from here. Actually, you have the swash plate adjustments, which I will show you in a couple of minutes, and then you can reverse the direction of the compensation of the gyro. Also, you can reverse the direction of the servos from here, and then you get out of there. And basically, this is based on your helicopter swash plate type. And then go forward, you can again reverse the servos here, the swash plate servos, and then here is you can set the angles of the swash plate from here by hitting any of these arrows, and these single ones here do the same thing but they just control one channel. But with the swash plate you can just control all three of them, so it makes it a little simpler, I guess. And here you can set the aileron and the elevator travels, which is excellent. So you can just set the servo travel to a limited area so that it doesn't touch anything at the ends. And you go here, you set the pitch angle. I'm not expert in this, so I'm not exactly I don't know this very well, and I don't have this in my device, so mine is actually set at pretty much at 0. Again, the servo limits, so you limit the servo. Also the servo trim, you adjust that. And then here is you just look how your servos are working, the controls are working, and then you either reverse them or keep them normal, and then you finish from here. Okay. So here's the advanced menu. Okay guys, now this is a very important place. Okay, here you have the roll P gain. The roll P gain at the top is actually basically again the sensitivity of the gyro against any kind of external factors. Okay, that's the sensitivity there. Now the roll I gain is what it makes it headlocking. Okay, so this is very important. Now the problem is when you set the gyro to headlocking mode, okay, the controls are completely different. So if this roll I gain goes up to 125, I believe, and goes down to 7 or 10 or 7 or something like that. Now what this is when this is at 120, basically the gyro is holding an angle. So when you turn it, when the gyro compensates, until you bring the gyro to its original position, it's holding that position. The servo is holding that position. So it's remembering the angle, and basically it's doing headlocking. But when you're at this mode, your controls are completely different. When you move your stick to one side, normally what you would expect is the servo to move the same amount and then stop when you stop the stick, right? I mean, whenever you move on the stick, you expect the servo to move that much. But when it's on the headlocking mode, because of the logic of, as far as I can understand, the vessel to react to your control stick, okay, when it's not reacting it, when it's on the floor, when you push the stick a little bit, the servo is traveling all the way down to the end point, so it's not stopping. So the stick is like, you move the stick a little bit and you stop, and the servo is traveling all the way to the end. Basically, if the vessel is in the air, obviously when you move the stick that much, when the vessel does that move, the gyro is going to compensate for that, and it's not going to do that. I mean, probably in theory, but the controls are different. It's confusing. So basically, if you don't want the gyro to do that, you cannot go to 120. So my happy medium was like 40. So actually I wanted the headlocking, but unfortunately when I do it 120, complete headlocking, it's not controllable. In my device that I built, it's not controllable. So as a happy medium, I could pull it up to 40. That's all I could do. So now the response to stick is like conventional, but it still is doing a little bit of headlocking. So that's something that you gotta find out, I guess. This acceleration and deceleration is related to the response of servo to the input. How fast it accelerates and how fast it decelerates. The RC deadband is giving a neutral area at the to the gyro in the mid area, and it's basically being null there, so it's not moving until the stick moves up to a point. So these are things that are not very critical and they can be adjusted. And we have the similar controls here for the tail rotor, the P gain, I gain, and things like that. My current setup though, for some reason, my tail rotor is not headlocking. This is at 120, but it's not headlocking. I don't know why. It's probably, it may be related again to the part over here. Actually, now I think about it, it may be related to this over here. Maybe I should play with this from normal to maybe to 0 area, and then try to find the medium there. This might be what it is. So other than that, that's pretty much it. I had a couple of times, 5 to 10 times I dealt with it for a while. It locked the computer crashed a couple of times, and then the screen froze, that I had to close down the software, open it again, and then the gyro froze a couple of times, and just locked all the servos and things like that while I was trying to adjust them. It happened a couple of times, but overall, I can say it's not bad. You're making a lot of adjustments, but yeah, it's kind of hard for people who didn't do this before to figure out what's going on, because the instructions are very insufficient, and there's not enough information. So I hope this helps somebody out there. And again, I couldn't learn all the features, but this is what I could learn to help people who are going to deal with this machine. Alright, thank you so much. Good night.